So here's the trigonometry missing sides exercise from my iMaths. I'm going to look at question 1 in this video. So I've drawn out the diagram on my pad for the first part of question 1, and it's got a 34-degree angle, a right angle there of course, and it's got a side of 3, and that's the longest side, so I've labelled it as the hypotenuse, or just hype for short. I know it's the longest side because it's opposite to the 90-degree angle. Now meanwhile, the x that we're trying to find out is opposite to the 34-degree angle. So I'm going to label that as op for opposite. It's the opposite side, and we've got a triangle where there are two pieces of information, one that we've got, one that we're trying to find out, and it involves the opposite and hypotenuse. So we need to remember our trig ratios, and we need to remember which one involves opposite and hypotenuse. So that's sine. Sine equals opposite over hypotenuse. So I can write down that in this particular triangle, sine of 34 degrees equals opposite over hypotenuse x over 3. And then when I've got a fraction, I generally like to get rid of it as quickly as possible. So x over 3, I'm interested in knowing what the whole of x is. So I'm multiplying by 3 to get the whole of x, but then I've got to do the same on the other side as well. So 3 sine 34, 3 times sine 34 is what x is equal to. So I've just multiplied both sides by 3 to get that x equals 3 sine 34, and that's something I can just work out on my calculator. Now on my calculator, you've got to press 34 first and then sine, but on most calculators, like a decent scientific calculator, it's the other way around, where you press sine first. Okay, so that's sine 34, and I've got to multiply it by 3. Again, I do that in a slightly different order on a better calculator, but it's 1.677. Let's round that to 6 there, and let's go back onto the My iMaths screen, and it says give your answers to 1 decimal place or better. Well, I'm going to give it to just 1 decimal place, 1.7. And then the next question says, the next question is this triangle, so I'll just draw that out on my pad. So by the magic of editing, that's already on my pad, and I'm going to try and identify the opposite, adjacent and hypotenuse in this triangle. So we've got the 19-degree angle, and across from it, or opposite from it, we've got a side that's called x. So that's the opposite side, op, and then there's the longest side is the hypotenuse, which is, we know, is the longest because it's opposite the 90-degree angle. And then that leaves us with the 7, which is the adjacent. Adjacent meaning next to, and it's the one that's next to the 19 that we're going to use, but it isn't the hypotenuse. So in this triangle we've got the opposite and the adjacent, and then if you remember your trig ratios, and usually in an exam they're given to you anyway, but tan equals opposite over adjacent is the one that we need to use in this problem. So applying that to this particular triangle, we've got tan of 19 degrees equals opposite over adjacent, x divided by 7, x over 7. Well, I'd like to know what a whole x is, so I'm going to multiply everything by 7 to get a whole x. So I've got to do the same thing on the other side, 7 times tan 19, or I can just write 7 tan 19 without any symbol in between. And let's just get the calculator on that. So on my calculator I've got to do it as 19 tan and then that times 7, but you've probably got a better scientific calculator that allows you to put things in the proper order. So 2.41 something, I'm going to round that to 2.4 to 1 decimal place. So by the way, these diagrams, you know, that's not really 19 degrees. So it's just a general diagram to illustrate the situation and where everything is in relation to everything else. But it's not the idea to get the answer from a scale diagram. Anyway, let's go over to the iMath screen and fill in that 2.4. 2.4, and then the next one is up here, so I'll do that on my pad now. So by the magic of editing, that's appeared on my pad, and I need to identify what everything is in this triangle. So the angle we are concerned with is the 66 up here. That's the one we're going to use. The 4 here is the longest side in the triangle. We know it's the longest because it's opposite the 90-degree angle, so that's the hypotenuse, which means that the x is next to the 66, but it's not the hypotenuse, so that makes it the adjacent. So we need to remember which trig ratio involves the adjacent and hypotenuse, and that is cos. Cos equals adjacent over hypotenuse. So in this particular case, we need to put in all the numbers we've got and apply the cos ratio to this triangle. So cos of, we're talking about a 66-degree angle, is equal to adjacent over hypotenuse x over 4. So I don't want to know what x over 4 is, I want to know what a whole x is. So I'm going to multiply both sides by 4 and get 4 cos 66 degrees. 4 times cos 66. So on my useless calculator, I've got to do 66 cos, do it in the wrong order, and then multiply it by 4. But if you've got a better calculator, then that will allow you to punch things in the right order. Anyway, I get 1.6, so let's go over to iMaths and put that in. So here we are, 1.6, and then we'll look at this triangle here. So magically that's appeared on my pad. The right angle's there, so the x must be the hypotenuse. It's the longest side, it's always opposite the right angle. The angle we're going to talk about is 28 degrees down here, so the 4.3 is next to it. It's, in other words, adjacent to it. So we are using whichever trig ratio involves adjacent and hypotenuse. Now that's cos, isn't it? So cos equals adjacent over hypotenuse is the ratio we're going to use for this one. So applying that to this particular triangle, that means we can say that cos of 28 degrees equals adjacent over hypotenuse 4.3 over x. Now this is the kind of question that people come unstuck on, where the unknown thing is at the bottom. So you have to do 2 steps to get to the unknown x and to get it on its own. So first of all, you need to get rid of the fraction, and to get rid of the fraction you multiply by x and you're left with 4.3. But then I need to multiply the other side by x as well. So x times cos 28 equals 4.3. I've multiplied both sides by x. I want to get the x bit on its own, so I now need to divide by the cos 28. So x equals the 4.3 that was there before divided by cos 28. So there's 2 steps to that, unlike the previous 3 questions, and that's because the unknown thing is at the bottom of the fraction, which makes it a little bit trickier. Anyway, so I've got to do 4.3 divided by cos 28. On my not very good calculator, I'm going to have to use the brackets. On a better calculator, you're able to just type that in as a fraction, as in the way that it appears there. So anyway, let's clear everything, and 4.3 divided by, open brackets, 28 cos of that, close brackets, equals, so 4.87 I'm getting, so I'll call that 4.9. Doesn't look unreasonable looking at the diagram. We'd expect it to be more than 4.3, although it's not a scale diagram. So 4.9, and on to the next one, which looks like that. So here's the diagram for that one. So we've got a 36-degree angle, and the 3.5 is opposite the 36-degree angle. So 3.5, I think it's centimeters, but the units don't matter so much because they're already on the iMaths thing anyway, so you just fill in the numerical answer. The x is the hypotenuse. It's the longest side, so not just because it looks the longest, but for the concrete reason that it's opposite to the 90-degree angle. So if it's across from the biggest angle, I don't want to use the word opposite too much because it confuses with opposite there, but the one that's across from the 90-degree angle is always going to be the hypotenuse. The biggest side is always going to be across from the biggest angle. So anyway, opposite and hypotenuse, that is sine. Sine equals opposite over hypotenuse, if I can write that legibly. So I'm going to write down everything I know about this triangle. So sine of 36 is equal to opposite over hypotenuse, 3.5 divided by x. So it's another of these ones where the unknown thing is in the denominator at the bottom of the fraction. So that is going to have to take me an extra step to isolate the x. So I'm multiplying both sides by x to get rid of the fraction. So instead of 3.5 over x, I've just got a whole 3.5. So I've done that by multiplying by x, but then I need to multiply by x the other side as well to maintain the balance. But I want to get the x bit on its own. Let's just fence off my diagram there. I want to get the x bit on its own, so I'm going to have to divide by the sine 36. So x equals 3.5 over sine 36, and then it's straight to the calculator for that. And obviously your calculator is better than mine. Your calculator will allow you to just punch that in as a fraction. I've got to do 3.5 divided by, open brackets, 36 sine, close brackets, equals 5.95. 5.95. So actually, if I do that to one decimal place, well, 5.9, but the 5 will make it round up to 6.0. And I've got a feeling that iMaths will want me to put in that 0 so that it knows that I haven't just done it to the nearest whole number. Or I could just put it in. It did say I'm allowed to put it in as one decimal place or better, so I could put it in as 5.95 like that to 2 decimals. But I think I'll actually see what happens if I put in 6.0. So over to the iMaths. So let's see what happens if we put in 6.0 like that. Okay, the last one. So here's the very rough, not to scale sketch of it. The right angle's up there, which makes that the hypotenuse. And we're not using the hypotenuse in this one. The 49-degree angle has x across from it, so x is the opposite. And the 5.2 is next to the 49-degree angle, but it's not the hypotenuse, so it must be the adjacent. So we're going to use tan, which is opposite over adjacent. And that's a little bit more space over here, I think. So putting in everything we know, tan of 49 degrees equals opposite over adjacent. That's x over, I'm a little bit surprised that the x isn't in the bottom in this question, but there we go, x over 5.2. So tan 49 equals x over 5.2. I'm going to multiply both sides by 5.2 to get rid of the fraction, giving me x on its own. So x equals 5.2 tan 49. So I've just multiplied. That's not very clear on screen, is it? Let's just do a better version of that. So multiplying both sides by 5.2, 5.2 tan 49 equals x. Let's just obliterate the heck out of that. Yep, so from here to here I've multiplied by 5.2. Multiplying by 5.2 here on the right just to get the x on its own and get rid of the fraction. But then I've got to multiply by 5.2 on the left as well. So where I had tan 49, I've now got 5.2 times tan 49. And I'm going to punch that into my calculator. So kind of got to do it backwards on this silly iPhone calculator. So 49 tan and then multiply it by 5.2 gives me 5.98. So 5.98, if I round it to one decimal, 5.9, but then the 8 makes it round up to 6.0. So I'm going to put 6.0 on iMaths. Not just 6, because 6 suggests I've rounded it to one nearest whole figure and not to one decimal place. So 6.0 again, and let's mark it. And that's satisfying.